Hey, welcome back to the channel. I got a unique power supply here. ELPAC Power Systems model number, let's see, Whiskey Romeo Indigo 4212. Power supply input 95 to 250 volts. AC, we're looking at 47 to 63 hertz. Draws 1.2 amps from the power source, output being DC 42 watt max, 12 volts and 3.5 amps over a very little nifty pin connector that you see right there. This power supply doesn't work. I've currently got it plugged into my isolation transformer variac dimbo tester. I'm not seeing any short on it. So what I'm going to do preliminary, we got to take some voltage measurements out of the pins. I really don't know the exact pin out, but we can determine why it's not charging batteries anymore. This goes to a PIR, which is basically test equipment used to measure ILS instrumentation out on the airfield, this being the power supply that charges it. You know, I haven't looked up any tech data on this power supply, but we can at least make some preliminary measurements. Okay, so I got nothing on this first pin, and what I'm doing is, you see how it's this way. I'm just going from this side and then over to the other side, measuring each pin. So from my point of view, I'm starting right and moving across to the left. So nothing on that first pin. I'm going to try my best not to short out any of these pins. Doesn't really seem like anything on that second pin. Third pin, nothing on there. Let's go to the fourth pin. Nothing on there. And the fifth pin. Oh, I don't even have this on the ground, and we're going to have to do this over again. All right. First pin, nothing. Second pin, nothing. Third pin, nothing again. Fourth pin, nothing. Fifth pin, nothing. So I'm not seeing 12 volts. We got to, on any of these pins, and we got to figure out the reason for that. Now, because this is a AC to DC power supply, we need to be very careful of how we work on this thing. You can see we got 4 Phillips head screws. That's going to remove the case. And of course, warning in here, looks to be in German and English. Do not open dangerous voltages inside. Obviously, there would be if we're talking about mains AC. But I can remove the AC power and get this apart, and we'll take a look at it. Okay, so here it is with the cover removed. Really just the 4 screws and the clamshell comes apart. And then yeah, we'll briefly remove this. It's always a potential that these bigger caps still have stored energy. I'll take my multimeter across this one just to see if there's anything stored on it. Looks like the negative lead is this fatter one sitting right here. Yeah, we'll check it just to see if there's any stored voltage. This appears to be a switch mode power supply given the size of the transformer in here. Looks like we have AC coming in. We have a fuse. We'll check it to see if it's blown or not. I don't think it is. What is this right here? 10, 250. So this and this is probably our safety caps. Yeah, it is X2 rated safety cap. Okay, so we've got 2 of them in line here. Let's see, varistor R1. Typically that's a resistor, but I believe this one's an actual varistor. So we've got, oh look, we got 2 more safety caps right here at the input to get rid of AC or any hum or noise coming over the AC line. You can see those 2 blue caps right there. C28, C27, several transistors, few more caps. We've got essentially resistors that have been tombstoned. You can see that they're put laterally, those resistors are probably going to be good. A lot of times when you have an issue in an AC to DC power supply that's switch mode like this one, ooh, we're missing a transformer right here. I wonder if that was removed at a later time. I'm not seeing anything there. Let's see, warning, replace fuse only with same type and rating. Wonder why this transformer right here is removed. Hopefully that's not the issue. Over on the back here, we actually have a rectifier. You see D1 is where it's labeled on the board. Let me see if I can get it in this shot here. It's right there. So that is providing, it's probably a full wave bridge rectifier. I see 4 pins on it, or 4 legs coming down to the bottom side of the board. My only concern is this missing component here. And hopefully that's not the reason for why we don't have an output. But, you know, we can find out. And if I don't know what is physically there, it's missing legs and everything, then it is most definitely not repairable. Okay, unless I get my hands on something else. So we're going to have DC conversion, and we probably actually have 12 volts coming over multiple legs. That's why we got multiple pins. Or it could just be that maybe we're developing a positive and a negative voltage, and that positive negative voltage could be, say, something like -6 and +6. Well, when you go from -6 to +6, what's that total voltage? That would be 12 volts. That can be another way in which you develop a positive 12 volts DC. Okay, instead of 0 to 12, you know, a ground, and then 12 volts on the positive side, you can use a -6 voltage rail and a +6 voltage rail. And then, you know, between the -6, say you apply your ground to the -6, positive to from your multimeter reads to the +6, it's going to be 12 volts total. Anyways, that's kind of rambling. What I really want to do is I just want to check the pin out, because none of these wires look like they're desoldered. They all appear to be on the board. I'm not seeing any cracks in the soldering joints. Actually, I do see one component right here that looks to be not really soldered in. I do see some cracks on that. And what is that? That is a capacitor sitting right there. As a matter of fact, as I move this cap up and down, I can see it moving on the board. So maybe that transformer isn't needed. Maybe that's our issue right there. I don't know. Let me get this under the microscope so you can actually see what I'm seeing a tad bit better. Just like I said, just for so y'all can see better what I'm talking about. Let me lift this up, orient myself on this board a bit. All right, there we go. And you come down. There's my finger. And right over here. All right, you can see these 2 posts right there. You see how they're not really secured on the board. And can I get my finger underneath that cap? I can. And then if I was to turn it sideways, you would actually could see me put pressure on this and then lifting up through those pads. See? So, hopefully that's the only issue. I guess I'll go over this and touch up all those soldered points and see if that fixes the issue. It could be that this missing transformer was used for a voltage rail that is no longer needed. Okay, that's always a possibility, or not used in this application, and that's always a possibility. So let me first make sure we have continuity between our pins from the plug, and I'll put my multimeter into just a continuity test. Okay, and we'll turn this over Actually, you know, I just dropped this down on an ESD mat. If there was anything over that cap, it probably shorted them out now. Of course, you know, this is conductive, but it's very low conductance because basically on ESD mats, you can look up, you can see, look, there you go, 160 something ohms. Anyways, where are those big caps at? The big one's over here, so that's the prongs on it, negative to positive. We got any stored voltage? And we do not. Okay, so that's the only one I was really concerned with. We do have these smaller ones down here, like this one right here. But yeah, no stored voltage, and we're going to call that good. Let's see, let's go to the ground side of this. Yeah, that is our ground plane, and that is okay. Let me go to this, I'll just go in the order of the pins I mentioned earlier, because I don't know what each pin goes to be honest. I know this is a horrible way of me trying to record this. That's resistance. So that is either the white or the red wire. Those two go there. All right, so those first two are probably white and red. Okay, since we have white and red going to these two pads here. Black, that follows all the way down through the board, and that is coming up here, jumping over there, and that's okay. So that was our ground, most likely. Yeah, that's the ground. Okay, let me go to pin 3. So we got 3 more wires, brown, yellow, and blue that's coming out. They're all tied to this point right here. Yeah, those 3 show up there. So it is very likely that that transformer might not be used in this application. But again, I won't know until I solder these items back in. None of these caps appear to be bulging or anything along that nature. There's a lot of elastic over them. Looks like we got a beefy inductor back here too. So yeah, let me just touch it up with a bit of solder and we'll see what happens. So I just touched up some points that look like the soldering was a bit iffy, and you know, quick fast forward session. I've plugged back in my AC mains. I need to turn it on. Keep in mind, when I work on power supplies, I do not wear my rings. Watches, rings, or dangling things. I don't want any metallic object near this. You got to practice precaution. I've been working on stuff like this for so long. You know, you can get what's the word I'm looking for here? When you do something that's so commonplace, you start ignoring it. You can get complacent. That's the word I'm looking for. And I really just don't want to do that. Not with something like this. I mean, at least good thing I got it on my dim bulb tester and stuff, so if I short something out, that's going to take the current load. But yeah, there's risk with this, folk. You need to practice good safety measures. So I don't encourage people to follow what I do exactly all the time. in my videos, because I've realized in some of my past videos I have gotten a bit complacent, if I'm being honest. Y'all have to practice good safety measures. Okay. Now I don't have AC turned on yet, so I need to reach over and turn on my dim bulb tester, and then we'll be checking our pin out again with my multimeter. So I probably should zoom out just a tad bit. There we go. Okay, let me turn on my dim bulb tester and we'll have AC applied. Okay, AC is now applied. Do we have any DC back? Do we have anything on DC? Nothing there. Nothing there. Nothing there. Or there. Or there. Okay, so we do not have DC. Let me check a few things. I'm going to put this on AC. Actually going to move this cord out of the way. And let's see. Yeah, I definitely have AC coming in. Mind you, yeah, it is coming to this transformer. Okay, so that could be the ultimate reason why we don't have any power out, because we do have it coming to the fuse, but we don't have it beyond the fuse, most likely anywhere else. I need to safely get this upside down so I can check the rectifier and make some measurements from there. I think that would be the next best thing to do. Again, I've worked on power supplies a lot. I don't recommend anybody to do what I do unless you're well experienced. You know that your precautions, how to keep safe, all that stuff. If you have any hesitation, don't do what I'm doing. Just don't. Okay. So we can see our AC mains coming in between these 2 points. There you go, 120 volts AC. Okay. We can see it coming to these leads right here. All right. This is our transformer that's going, it's most likely a 1-for-1. And what I mean by that is there's no differentiation between the primary and secondary transformer, or primary and secondary coils. Okay, so it's just providing us isolation from the AC mains over to the other side. That is my guess. I don't know for sure until I look up what is our full wave bridge rectifier over here. But if I put this on DC, you can see how this is coupled across. Okay, and then it comes to our full wave bridge rectifier. All right, well, it's obviously not coming there because we don't have that transformer. We don't, it's not there. We can see where it's tapped off to provide other rectification, because we do have some other MOSFETs and stuff, or probably double diodes on the board, but they're just not there. Thus, we don't have an output. So what I need to determine is, if I can, I'm not too sure if I can, what type of transformer goes into this position right here. All right, so I've decided to make life a tad bit easier for myself. As you can see, I've got a light power supply sitting over here on the right. Found this one off of eBay. Roughly 20 something, maybe $30 with including shipping. But we can definitively now see the component that's missing here. Now, what's odd to me is labeled on the board is L1, which would stand for an inductor. And yeah, it's very possible that this isn't an inductor with different coils and say a ferrite rod moving that's coming up the center. And when you look at it from the side profile here, you can see all the segregated windings. Okay, but I'm willing to believe that this is being used more so for, say, like a step down transformer. So really at this point, we just need to determine what that ratio is. So if I was to take this and position it upside down, okay, just like I did with the other one when we were checking with our multimeter, the other side of the board, okay, and had it on AC, and we went across these pins and obviously didn't see anything on this side. We should be able to find our 120 here and then see what's coming up over on this side. Again, if you're following along, if you're doing this yourself, you can see my rings and everything are off. You know, be confident and, or comfortable in what you're doing. And if you lack the confidence in what you're doing, don't follow what I'm doing. But I'm going to plug this into my dim bulb tester, variac, and isolation transformer. We're going to power it up. I'm going to measure AC across here, measure AC across these terminals. Okay. And then I just kind of want to make DC measurements across the outputs here. I think our commons were here, our V pluses were here, and then our ground, if I'm not mistaken, was the black wire. Yeah, our ground showed up right here. Okay, so we can see what we should have on those pins, and if that DC measurement is steady, what I'll do is I'll desolder this transformer, okay, out of this board, and we'll put it into this board over here, and we'll see if it functions. And then eventually I might go and try to find a suitable replacement for this. I'll reserve that for another video though, but you let me know if you want to see me do the research and try to get this power supply operational after moving the component over and getting this one working. Now, the reason why I just won't keep this one is because, you know, there are some slight differences. Somebody put in a different connector on the end for their power supply. This one only being essentially 3 wires, the ground, the common, and the voltage. So whatever that is, different connector. I don't want to deal with desoldering all this and swapping over the lead. I'd rather just do the transformer that we have right there. But yeah, let me get this hooked up and we'll make some measurements. And here we go. Like I said, I believe it's a step down transformer, but the ratio of step down voltage to input voltage, I don't know. So we're about to verify that. I'll do this lead and my own AC, good. This lead over here. There goes our 120. And what do I have coming over the other side? It's not a step down transformer. Okay, so it's a 1-for-1. All right, well, with that being said, we've at least verified that it's just an isolation transformer. Okay, that's fine. So we would have rectification here. Let me get to my ground. Now, this would be better if I didn't have to dangle my hand across so many things. I hate doing stuff this way. But I'm going to measure DC there. That's going to be AC. AC, so let's see what. Okay. Let me go up this way. Interesting. Interesting. Okay. Interesting. Okay, so at least got those measurements I can go back and watch the video and look at. But let's check our common and our voltage. So do I have anything here on common? No, that's basically going to be a return. Okay. What do I have here? Oh, I'm still on AC. Let me go back this way. Okay, 0 on common and 12 volts. So essentially this is a 12 volt supply, as you know, we saw on the back. So let me and that voltage is pretty steady. So what I'm going to do is remove this transformer right here. Actually unplug it, get it off the off AC. We're going to remove this transformer, get it put over to here, and see if this comes back to life for us, or if we're going to have any other issues. Pretty easy to put that transformer in. Desolder from one board into this board. Now put in my AC drop cord, but I haven't turned on my AC from the dim bulb tester. So we're going to see in real time if I made any mistakes or if there's any other issues with this board, because if I flip over that switch and something shorted, it's going to go poof, and it's not going to look very pleasant. So let's engage our squint factor for a second. Uh-oh. No issues from what I can tell. It seems to have powered up. I think I heard a cap charge, but I don't see any smoke or anything. So let's check some voltages. We'll work our way back through this one more time. Okay. We're going to look at the AC. Yep, 120. 120. Here goes our ground. And this is where we're going to get all of our rectification. Yeah, so that looked very similar to previous. Let me put it on to DC. And let's go from here to common. Yep. Then from there to our V plus. And I'm not seeing anything here. Should have 12 volts. So why do I not have 12 volts? We still have more issues. Oh no. Well, at least now we know that we have more issues, and I've got more troubleshooting that I need to accomplish. So that was the common. Can we do common to this? Oh, we get 12 volts that way. Not from the ground. Well, this might actually work. Let me go to our pin here. What are we getting on our pin? Might just because of the way this one's wired up differently. So I could be wrong. Going from my pin, and we'll start with right, going to the left. Let's see, can I bring this into focus here? Alright. Pin 1, pin 2, pin 3, pin 4, pin 5. So it's probably from our common pin to that we need our 12 volts. And I can see that now. Okay. So was that the same with the other side? I don't think it was. The only other thing I can do is plug it into the device that it was being used for and see if it will start charging the batteries. We do have 12 volts now though, so that's good. I'm just not seeing it between this, which should be our ground pin, and our V plus pin, but I am seeing it between our common and this. But like I said, it could just be because of how we're wired up differently. Other than that, there could also be an issue with the board, but I would need to go back and make some measurements to see if that is correct or not. Actually, probably should go back and watch my video. So yeah, I definitely do need to poke around my board for a bit, going back and watching the video. One thing that I did notice, I'll just go ahead and show this to you right here. Might not be incredibly visible, but on this pin coming off of one of our MOSFETs or power transistors, this guy right here, there's a ring around that pin. That solder is completely broke. I don't believe that this is soldered in well enough anymore because I'm completely cracked all around the ring of that pin. So I need to go back through and touch up some more soldered some of these pads that were soldered to, and you know, start poking around some other components as well. Okay, as I probe and troubleshoot this more, I've come to the realization that we're actually good here, because that ground, it actually even is present over here on my AC side of my supply. Okay, so that all ties together, which is basically telling me that this is more so acting as a shield for my cable at the end. Where I should be getting 12 volts was between common and here, as I was seeing on that supply. But for some reason on this one, I probably should have measured. I probably would have gotten 12 volts between common and here. So we'll talk about plus and minus. But I was seeing it from ground to here as well, and I believe there actually needs to be separation in our circuit from here. So I think there's an actual problem with this board that I brought over to repair this one. So that means that this one as well is going to have to be troubleshot at some point. And when I look on the board, I'm starting to see some soldering issues and other things. But for now, I believe that this right here is in fact working. So really the only thing left for me to do is to get it over to the equipment I need to use it on and plug it in and make sure that it charges the battery. Well, it'd be kind of hard for me to film this, but we've got two power supplies. This is a known good. Now I'm going to compare it to one I fixed, so we can make sure that we actually truly have isolation between our ground and then our common and positive pins. I'll try to position somewhere where we can do this check and I can record at the same time. Okay, so here's a known good. If I go between here, and I'll put my multimeter there on the ground. Well, you can't even see that. There we go. Can't scoot that way. There we go. So, are we isolated? The answer is yes. We are isolated between those 2 points. Now it does move a little, but then afterwards it disappears. So that means that I should have, if I was to go across that pin, this one right here, 12 volts, yes, because remember these 3 pins and those 2 pins are common, and then our 12 volt source. So this tells me that the one that we used to repair, and this is the one that we repaired, that it does have an isolation issue between the ground and the common. Alright, which is why I was getting a voltage reading between ground and our 12 volt rail, which I shouldn't have. So let's see, this one, yes, and we got our 12 volts. Okay, so this is fully repaired. Let's go plug it into some equipment and make sure that the equipment charges. And so yeah, here we go, both plugged in and both charging the battery on these portable ILS VOR receivers, which is what we use them for, as our supplies and battery chargers. Awesome. So most likely there's probably some bad caps in the ELPAC that I bought. It's leaking current, and that's probably why there's not enough isolation between the ground and common. You know, I did a diode check between 2, and I positive on ground, negative on the common rail, and I saw a voltage drop of 0.2, which read like a diode. So there are diodes in the power supply, but I believe we have some bad caps, and that's why I'm seeing that. I don't know just yet, but I will make that determination if I can find and source a high frequency, like an E44 type isolation transformer for that 120 volts. I believe the one I was using had a ferrite core. But anyways, that's besides the point. You let me know if you want to see me try to repair that third one that I used and cannibalize to get this one over here operational in the comments. But we have this one fully working, and we know our pinouts, and we know what we should see between the outside shielding and the common and the positive pin now. And yay, it's repaired. So if you've enjoyed this video, please let me know by liking this video. Please subscribe if you're new to this channel. If you're in need of something repaired, you know, you can go to my main page, and or actually in all these videos in the description will take you to my business site, where you can read up on how to get a hold of me for repairs. Either way, that's enough rambling. Thank you for taking the time to watch this video. Take care and goodbye.
Bark.